Welcome everyone to Safe and Efficient Single Pilot Operations. I'm Matt Thurber, Editor-in-Chief of AIN Publications, and we'd like to thank you for joining us for today's webinar. Today we're going to learn more about what kind of systems avionics manufacturers are developing to help improve single pilot safety, and also what we can learn from experienced pilots flying in single pilot operations. Joining us today are Gloria Hav, CEO of Universal Avionics, which is developing with its parent company Elbit Systems a wearable head-up display, and Charlie Precourt, Chairman of the Citation Jet Pilots Safety Committee and EAA Vice Chairman and Safety Committee Chairman. And Charlie's also a former NASA astronaut, safety expert, and he owns and flies his own Citation jet. We welcome all your questions, and you can just type questions in the webinar question field, and we'll address these towards the end of the webinar.
See if everybody hear us. Can everybody hear us? Okay. Okay, thank you, everybody. We just wanted to make sure we could check. Thank you.
Okay. So before we get started, we're going to run our first poll question. We'll give you up to 60 seconds to select your answer, and then we'll highlight the results. And the first question is, what is the greatest challenge our industry faces in using new technology to enable safe single pilot operations, including in flight decks that currently require 2 pilots? Launch that poll. So we're going to start first with Charlie Precourt, and he's going to discuss some unique ideas that he's developed working with the Citation jet pilots on single pilot safety. Charlie, handing it over to you.
Well, thank you, Matt, and thanks for having me. The Citation Jet Pilots Association has been doing a significant amount of work over the last couple of years to address the challenges of single pilot flight operations. And when I joined that effort with them, we thought that there was a unique opportunity to share our efforts with the rest of general aviation. And so I thank you for this opportunity to do just that, because some of the more challenging single pilot operations are indeed with operating citations, very high performance, long range, and therefore aircraft that are exposed to some of the unique challenges of IFR and other risks in flying that we learned through the experience of the association members could use some assistance with an approach to safety that the entire Citation Jet Pilots Association has grappled with here in the last couple of years. And so the safety committee that was formed really was put together to address some of the issues our members were seeing. And what we came to realize is there were 3 key areas of focus that we thought would really be of significant impact. There were, in fact, a couple of particular accidents that the members had friends involved in that were very significant events for us. When you have a friend in an accident, it's very impactful, obviously. And the three key areas that those taught us we needed to focus on were training, more on that in a minute, development of standard operating practices, and then proper use of advanced technologies, which I'll introduce and then Dror can amplify, as you'll see later. The focus on the most common trouble spots, in fact, come from the types of accidents and incidents that some of our members either witnessed or were involved in-flight loss of control, and for the light jet operators, runway overruns. Matter of fact, the most common incident or accident is a runway overrun with aircraft that have higher approach speeds than other smaller light general aviation aircraft. There's a lot going on within our area of interest and our initiative, and anybody can access what we're doing with the CJP website safety page. If you go to the link there, you'll see what we've been doing, and you can see some more particular examples of the kinds of things that I'll talk about here in the next few slides. So if you'll switch to the next slide, I'll dive into the first of the key focus areas, which is training. The first thing we all recognized, and there are 700 members in this association, and there's an annual convention, and one of the things that we instituted was a safety stand down, a full day and a half of another day of dedicated presentations on safety, lessons learned from incidents, and speakers that are focused on how to operate these jets. And a commitment to training is part of this whole conversation. For those who fly single pilot Part 91 in a citation, an annual check ride in the simulator for 6158, or an annual flight with a check airman who is qualified to provide as a DPE, an in-aircraft check ride, are really all you need to do. But really, to be up on the step, of course, you have to be doing and committing to way more than the minimum. You know, and from FAR Part 91, obviously, you know, there's very minimal requirements for currency to be able to carry friends and family. You know, 3 takeoffs and landings within 90 days, 6 approaches in 6 months, and so forth. But yeah, we all had to ask ourselves, don't our family and friends deserve better? And so the thing that we did to focus on additional training goes into things like making sure that we give ourselves the opportunity to work on scenario-based training, and then also understanding what is the standard we're trying to achieve. What does good look like? There was an accident that many of our listeners may have heard about, a Learjet crew for a corporate operator that went into Teterboro, and they lost the aircraft in a loss of control day VFR, trying to do a circle where they initiated the circle way too late. For anybody interested, you can go online and listen to the cockpit recording. And it is unfortunately an example of what good doesn't look like in terms of crew discipline, crew coordination, and the management of a flight. And so what we've been trying to do is show videos to our members on the website that take a good example and a bad example of how to confront a given challenge in a flight phase. And thereby setting standards for ourselves as to what you should see as a result in your training. On top of that, we established what we call the Gold Standard Safety Award. Those who commit within the association to going beyond the minimum would be recognized at the annual convention with a gold medallion mounted on a plaque. And last year was the first year we awarded it. We had over 45 of our members that were awarded that award, which is a very significant result for the first year. And what that requires is that they not only do the minimum 6158, but they do a second 6158 type of exercise during the year, and then they commit to taking on some other type of training, like we call it rounding out training, getting another rating, taking upset recovery training, getting in the altitude chamber, and so forth. So that has actually tapped into the competitive spirit of our members that want to see themselves doing better. And as a matter of fact, from a culture of continuous improvement, We believe in education, not legislation, and if you can tap into an individual's competitive spirit, which among the pilot culture, there's a lot of that, you can make a lot more ground than if you try to dictate what people should be doing. So the training piece is huge. We're working with the sim providers to increase the exposure to scenario-based training. And what I mean by that is up to and including when there is an incident like a runway overrun or a loss of control. There were a couple of very famous loss of control incidents, one out of Cleveland with a Citation CJ4, lost control shortly after takeoff with extremely high climb rate that wasn't controlled with an early level off and a 90-degree right turn out over a dark lake. Disorientation and loss of control, unfortunate result. But scenarios can be built like those in the simulator that our members can, and all pilots can deal with in the simulator. So training is a big pursuit for us to improve and broaden so that the experience base of the operators is going to meet the challenges they might run into in flight. The next area of focus on the next chart has to do with what we call standard operating practices. It became pretty obvious to us as we worked with our members that most people had a variety of ways of operating. What we mean by standard operating practice is that when there is no governed method by the manufacturer's operating handbook, that we have the right to create techniques to achieve a flight phase, then we want to make those standard. We want to pick the best techniques, we want to make them our standard practices, and we want our members to commit to doing them that way. And what you find is when you adopt a set of standard operating practices, you're doing the same operation the same way every time. You build muscle memory, and you also build bandwidth to manage the unexpected. And what that means is when something isn't right, you'll notice it more. You're more able to notice it and respond to it. So what do we mean by SOP? So we adopt the most widely accepted techniques that are the most successful in accomplishing a particular maneuver or flight phase. And as a very simple example, we all know we got to put the gear down per the POH and for our health, but when and where do you do it? And I've seen a variety of techniques in there. And we adopt, at the final approach fix or prior to the final approach descent as an SOP, and everybody does it at the same time, and it becomes part of your routine. It's a very simple example, but we have about a 12-page book of a variety of things that we consider our best standard operating practices. And they run the gamut from how do we create discipline around things like crew rest? What do we do to deal with carrying passengers? How do we govern management of hazardous materials on board, lithium batteries and so forth, and all the way to what is the right way to consider increasing our minimums when we only have 100 hours in the jet or less until we gain experience. So we have a whole slew of what we call our standard operating practices. And we went through those as we introduced them at last year's safety stand down, and the members have adopted those, and we're getting quite a bit of good feedback. I want to emphasize the word practice versus procedure in the term SOP. Again, this is with the theory of we don't want to regulate, we want to educate. And on top of that, we don't want to tell our folks how to fly their jet. We want to give them some really good things to think about when they do. And that's why these SOPs are those good things to think about and adopt. In an airline or in a professional flight department, SOPs, the P usually is procedure because the boss pays our folks to do them. And if you don't fly by the SOPs, you won't be flying for that outfit. But in Part 91, nobody's paying you to be following someone else's procedure, but these best practices are those that we put out there that ought to be used unless the individual deliberately chooses his own alternative for his own rationale that's well thought through. And we use mentor pilots within our community to be able to discuss those things because certain flight operations may justify a deviation from our practice, and we work through those with the members. And then finally, on the next page, I talk about the appropriate use of technologies. And what we have found is that there are two places in flight where we could probably advance the technology to our benefit. The first is in managing risk prior to a flight. This flight risk assessment tool concept has been out there for many years. We have found that most pilots, some are very disciplined in how they use it. Most will look at it and I don't want to use the word pencil whip it, but they can rationalize their way through finding a green result because the questions can be so subjective. What we would like to see developed, and we're working with some of the providers to do this, is to take our SOPs and to take the conditions of a given flight, and once a pilot files a flight plan on their favorite app, that it would pop back an automatic answer as to what the risk assessment for that flight is. And that could be done by an algorithm when these apps know how much you've flown recently, what kinds of flights you've made, what time of day they were, what kind of weather there was, and then compares that against the kind of flight you're about to make, what kind of weather there is, what time of day you're departing, are you landing in your circadian low. It could pop back a thing that says, you know, this is a yellow flight for you because of XYZ. You ought to consider the following alternatives. It would be not a user demanding process to provide that answer. It'd be automated, number one, and the user could choose to follow it or not. But when that user sees those things pop up, it's kind of like, you know, when you do an Uber ride, before you go take your next ride with an Uber driver, it pops up and asks for a critique of the last driver, and do you want to give them a tip? You know, this thing could pop up before your next flight and say, here's the kinds of flying you've done recently, this is what's out of the ordinary, and give you a little risk assessment that's not as so subjective that the operator is making the call, and it gets a lot more objectivity in it. So we think there's some really good potential there. And then on the far side, we think that there could be automated post-flight things on very unique specified phases of flight where we want to make every flight a training flight. So for example, the avionics that we fly today can collect and Wi-Fi information for things like, in our world, we have runway overruns as an example of a problem that we need to deal with. How about every landing, the individual gets a pop-up after the landing or after the flight on the app that says you were 75 feet at the threshold and you were VREF plus 10. You weren't on VREF and you weren't at 50 feet. Therefore, you just added a potential 25-30% to your expected landing distance. And if it came back that way every single flight, the individual would be prompted again in an automatic way of things to look for on the next flight. And there's a huge amount of potential here, again, because this data is collected automatically, and because our tablets have now got Wi-Fi connectivity, and we think there's some great potential there as well. We are working again with a lot of the providers to advance these thoughts as future potentials. And what is important about this is what we find is that a lot of our operators, especially single pilot operators, won't take the time to dive into additional apps that require a lot of user interface and activity. So we would think that this could be well adopted because of its ease of use. And then finally, we focused on the pre-flight and the post-flight because we want to make sure we avoid overuse of in-flight real-time co-pilot functions that can actually have unintended consequences of distraction. You'll see Dror has actually addressed that quite well with his advanced avionics that he wants to introduce. So summarizing that on my last slide here, and I'll jump off the stage, single pilot safety, the track record really is improving, and it's due to a lot of efforts that people are making. The Null report, if you watch that, shows a multi-year downward trend in accidents, but obviously more is needed. We'll never be there. We'll never want to stop improving. And in single pilot ops, there are increased risk factors. So we think the proper use of training, knowing what good looks like, keeping your friends and family safe through training is important. Developing and adhering to SOPs and taking advantage of automation in appropriate ways are really three key focus areas for us.
Thank you very much, Charlie, for the excellent presentation. We're going to run the second poll question now. And the question is, what attributes would an automatic application need to be a feasible solution to future adoption of single pilot operations. And we'll give 60 seconds for people to chime in on this. And stand by. Answers are coming in. Interesting results. It looks like the majority are choosing the answer easy to use with very little heads down activity required. The second most popular answer is tightly integrated with onboard avionics. Number 3, monitoring of the single pilot's health. Thank you very much. Now I'm going to hand it off to Dror.
Hello, everybody. So, single pilot operation has been the holy grail for many of the operators since the big shortage in pilots in the industry and the need to increase capacity and occupy those platforms with pilots. So, but again, this thing is not new in the industry. Fighters has been operated as a single pilot operation like forever. But this has been unique because those pilots are been carefully selected and heavily trained over years. As airplanes become more and more sophisticated, there was a need to introduce new technologies that will help them and support them in their mission flying. And if we go to the next slide, which will be a typical F-16 cockpit. You can see that, next slide, please. You can see a traditional F-16 cockpit with a head-up display, where it was first introduced back in the early 80s to support flying. And this has been flying since there in any fighters, and now we see more and more adaptation of this technology into the business aviation. Early 90s, we start to see super mid-size airplane and above adopting head-up display technology. And in slide number 14, you'll see one of the latest one that produced by Elbit and Universal is the Falcon Eye system that was adopted into the business aviation market. Now, the incentive to go into the business aviation market, and again, we are talking about heavy and quite expensive airplanes, was to be able to deal with mostly low visibility condition. And a traditional low visibility condition in slide number 15 is the ability to land in Cat 1, 2, and 3 airports, even if the runway and the infrastructure is limiting. And the way to do that was to install a camera in front of the airplane. You can see two typical installations of our product, one on a Gulfstream and another one on a Falcon, that essentially what it does, it provides a pilot an image which is almost uncomparable to what you can achieve just by looking outside the windshield. A typical one will be in slide 16, the next one. In this image, that will come up shortly. What we are doing is we are projecting a pilot, an image, a monochromatic image, a green one, that is composed of 3 main elements. One of them, you can see above the horizon line, is a synthetically generated 3-dimensional representation of the real world, what we call synthetic vision over head-up display. This information will be there regardless of the weather condition and every day and every time. The second part which we project to the pilot is below the horizon line, is an EVS image. In this case, it's a multispectral imagery combined of several different sensors. And all superimposed on the real environment. This image will be able to penetrate low visibility condition, haze, night, and other means that obstruct the pilot from viewing the outside world. And on top of those two layers, we add the symbology that can be as rich as the platform can provide. Essentially, the most important one is obviously the altitude velocity and horizon line, but most importantly is the flight path vector that indicates where the airplane is actually heading rather than just pointing, allows the pilot to understand where the airplane is heading and where is the expected touchdown according to the current velocity and current speed. All of those applications about head-up display and enhanced vision for business aviation was initially supported by high regulation, and they're all about return of investment. On the next slide, number 17, you'll see the regulation coming from the FAA that enable pilots today to dispatch to runway which are where the reported weather is below the minimas, the published minimas. It enabled the pilot using this kind of technology to start, even if they're operating under Part 135 air charter, they can start the approach even if the weather is below minimum, and obviously descend below decision height all the way down to the ground based upon this image. It means that you can use electronics means in lieu of natural vision. All in all, we are talking about money generating piece of equipment. And when the big investment needs to be justified, we can put the numbers there to show that it is there. It allows them to do more with this equipment and to go to additional airports which are not accessible to non-equipped airplanes. But when we look at this piece of information, piece of technology, we believe it's a big enabler for tomorrow's operation, because what it does, it allows them, the pilot, to reduce significantly the workload and allow them to operate the cockpit more easily. And this is the topic I would like to discuss in particular in this presentation. In number 18, you'll see the latest development by Universal and Elbit. It's a Skylines wearable display. It's essentially head-worn display, head-mounted display that is certified and acts as a certified head-up display equipment. And what it does, for the first time, it allows two main things to the industry. The first one is it allows the operators to install this technology, the head-up display technology, on small and medium airplanes, and also on an existing one. Those are not coming from the factory. So it opens up a big market which was until very lately not accessible for EFVS technology, and even for the small citation which has small cockpit, it's very hard to fit a traditional projector and a head-up display. Now this technology become available, and this is important because we believe that single pilot operation will be heavily dependent upon, or will be heavily supported by, enhanced flight vision operation. The second thing is that for the first time, we enable the pilot to get information outside of his primary field of view, outside of the limited 30 to 40 degrees field of view head-up display, which exists today. And this will enable him to get much more of what is out there, more information, and I will demonstrate some of the application that can be used by the fact that now we can provide information or display information in a conformal way, regardless where the pilot is looking. So we'll jump to the next slide, and I'm going to start with the basics. The basics, or the basic piloting task, is to try to determine where the airplane is going to land. Now, this for a highly qualified pilot will look like a simple task, but in fact, it's not a really simple one to do, And it requires a lot of experience and pilot flight hours in order to determine that based upon the image that you see or the picture that you get of the runway from your windshield, from the cockpit, whether it's going to be a short or a long or a regular touchdown landing. And the reason for that is that this picture doesn't tell the whole story. The whole story in the next slide is not about how does it look like, it's about what will be the level of energy that you have in your airplane, and actually where the airplane is actually flying to, not pointing to. And in this case, you can see that you can get perfectly good picture, or I'm saying depiction of the runway from the cockpit, but in fact, you're going to do tremendously short landing that has been done in San Francisco with this 777 because the pilot didn't have an indication or didn't feel that he's going to do a short landing. On the contrary, you can do a very long landing with the same good looking imagery coming from the cockpit, looking from the cockpit. So whenever you start to superposition all the information that is currently exists in the cockpit, inertial system, horizon line, and other data, acceleration data, in slide number 21, you start to see that the whole thing become much easier to understand. So if you take this image and superposition the flight path vector, you start to see exactly where the airplane is going to head to and determine that this one is going to be a good landing for you. Another one that is very beneficial to the pilot is try to understand or get visual representation in symbology while looking out instead of looking down to the cockpit, which is obviously not something you want to do when you're about 100 feet towards landing, like 12 seconds towards landing, is to see outside, by looking outside, what is your energy state, meaning how fast are you? Are you too fast according to your recommended recommended speed limit? And to make sure that even if you're going to hit the runway in the right place, you're going to do it, you're going to the right energy state and not too fast. One last thing that become more and more requested by the customers is to have what we call a pitch flare indication, which helps the pilot with the flare task. Flare task can be relatively simple if you are going in the right speed and the right angle and the runway is rather flat. But it starts to be more and more sophisticated and challenging when we start to talk about steep approaches, carved runways, or high energy or low energy situations. So whenever you are stable, when you do regular runway in the right angle, you need to start to flare. Depends on your platform, can be between 50 to 30 to 20 feet. And you learn that quite well. But whenever you start to talk about steep approach up to 6.6 degrees, which looks very, very steep, or you're going to approach the runway very energetic or low energetic, now flare is going to look differently, and the flare pitch and the flare cue that you have in your head-up display really helps with that particular task on the last phase of flight. So all in all, we are talking about helping the single pilot to do this regular landing day and night in all weather conditions. Now, we'll look into the future, and with the single pilot cockpits, we believe that they need to be helped significantly in many other areas. And the two main areas is, first of all, to reduce the workload, especially at night and low visibility conditions. Now, whoever of us has some piloting experience knows that even if it's a clear day, but it's nighttime, and you are about to approach a runway, which is surrounded by terrain or by a challenging terrain, the workload of the pilot increases significantly. Did I make a mistake? Did I approach the runway in the right angle? Do I really sure that I'm not going to hit a mountain in a few seconds? Now, just imagine how does it look like, and you can see here an imagery taken from an airport in the French Alps in Chambéry. How does it look like when it's a dark night, completely dark night on the outside, and when you stick your head toward and throughout an enhanced vision system, and you start to see the terrain generated by the synthetic vision or on the EVS on the downside of the picture, with a full indication, how are you comparing to the center line and where is the runway? How does it affect the pilot, or especially the single pilot one? How does it reduce the workload and allow him to do more tasks more easily and less mistakes, obviously, in the normal operation towards landing? So we believe that one of the benefits is around supporting the pilot, the single one, especially the single one, which doesn't have the ability to consult with another pilot or look on the right side and say, hey, what do you think? Double check, cross check me that we're not going to hit something very soon. And get the confidence that he's in the right path, supported by a sensor imagery from a camera. Now, we'll switch even further into the future, and now we'll start to talk about ADS-B applications. ADS-B out is going to be mandated by January 2020, and most of the airplanes are going to be equipped, already equipped with this kind of technology, but the big leapfrog towards the future will be when airplanes start to pick up or install ADS-B in, which will allow them to develop ADS-B in safety applications. Now you can see a demonstration or an illustration of ADS-B in application, which collects all the data being transmitted by the different airplanes in the vicinity of this airplane. The ADS-B out, which transmits location and intention and velocity. And it all being superpositioned on a down, displayed on a down display. And this will be typical imagery coming from a dense airport trying to land. Now, honestly, as a pilot, this is a scary image because it shows a lot of activity out there. So what does it mean? What do I need to do with it? How can I visually identify those airplanes and make sure that I'm not going into a place where it's too crowded, or double check the ATC controller, making sure that he didn't make any mistake, and hopefully to be able to visually separate for some of them and do a visual landing rather than an IFR approach. Now, one of the applications we are working in, and the key thing is leverage our ability to present those traffic information regardless where the pilot is looking at, rather than on a fixed head-up display, is shown on slide 24, is that we can take this information, this ADS-B information, and point the specific traffic with a unique symbol. This unique symbol will surround this traffic and will be able to show you where a particular traffic is actually located on the real world, helping you to establish visual identification and hopefully later visual separation from this traffic. All in all, this kind of application it's not completely new, to be honest. It has been deployed more than 20 years ago on the military, used for military missions, for example, radar lock and interceptions. But this function on the commercial aviation will have a great value initially for safety, but later on to be able to establish eye contact with other airplanes and to be able to perform on separation, going visually. Now, the last one that I want to talk about in terms of future application is the heavy duty of using flight management system during flight. Now, flight management system is a key function in any airplane, and it's an essential one. A lot of time is being spent on the ground to prepare the airplanes towards departure and program it towards all the flight phase, and sometimes during the cruise.
where you need to modify or calculate fuels or decide upon your flight level, the correct flight level. The problem with flight management system operation or activities start to happen whenever you approach towards landing or departure, and when you're being asked to do some changes on your flight plan. Those changes are sometimes being requested by the ATC controller or due to some unexpected constraints that happens during flight. And what typically will happen in this phase is that one of the two pilots needs to look down and program the flight management system, removing his attention from the outside from the regular piloting tasks. When we talk about, first of all, even with the two cockpit operation, this can be quite challenging because we're losing one pilot looking out, monitoring, and typically the pilot flying will also put a glance inside, give a glance and try to make sure that the other pilot is doing that in the right way. But when we talk about single pilot operation, it can be very, very challenging. So nobody's now looking outside, making sure that we're flying in the right direction. And especially when we're talking about critical phase of flight, this will be high deviation, attention deviation from the regular piloting task towards landing. Now, what we have developed is an application which we call interactive synthetic vision. We will share with you, if you go to the next slide, 26, you will see a glimpse of it. We will share with you with an email a link to two videos which demonstrate how this application works. And the idea behind this application, if you can flip to slide number 26, is to have everything that you need to see superimposed outside, while you are able to actually look and point the cursor on those functions, on all those places you need to go, bring out menus, select all those functions that needs to be selected on the flight management system, and to do all of it without shifting your attention from the outside, from the outside world, and without to turn your side inside the cockpit and lose understanding where you're heading and where the airplane is flying to. So we are talking about what we call fly by sight rather than regular flying. So now you can pinpoint the place you want to head to. You can bring up a menu. You can select a runway and an approach, and you can program the whole thing without even touch, or you move your hands from the stick and throttle, and without to touch the flight management system, even for from a single moment. And this is a game changer when we talk about helicopter operation, air transport operation, and business aviation, and mostly flying. And the biggest benefit we see is for those single pilot operators which really need that help with respect to flying and without shifting their attention from where the airplane is flying to the cockpit itself. Now again, those will be sent to you, those two links, and you can get an impression how it really look like in live, in video, and try to imagine how the future is going to look like. So I'll jump to my summary, to the last slide. So single pilot operation has been utilizing head-up display operation on the military for many, many years. Lately, we start to see more and more sensors connected into those head-up display. The latest state of the art JSF has those cameras connected to the head-worn display or the helmet display, allowing the similar way of operation. On top of it, we start to see superimposed information, all kinds of information displayed over the image. Now, it has been done in the military for a long time, years now. Now we start to see how this technology start to penetrate, how much it will help to reduce the workload and increase safety, and how it's going to penetrate it to the commercial aviation and business aviation world, we believe those will be key technologies for the future. They will be standard on any airplane. I truly believe in it. And the whole team truly believe in that as a big enabler to future operations. So I'm done with my part. I'm going to wait for some questions.
Great. Thank you very much, Dror. That's fascinating stuff. And just curious, the head-mounted display now, that's going to go into commercial operation in an ATR twin turboprop, correct?
Yes, the first one the first entry into service is with 2 airlines this summertime, but we have many others that will follow soon after them. Yeah, but it will start with airlines at the beginning.
Very good. Okay, and we do have some questions to answer, and if anyone has a question, please go ahead and type it into the question field. I'll start with Charlie, and we have a question asking if there's any data that shows if single pilot operations are less safe than a 2-pilot flight deck. Charlie, are you aware of any data on that?
It's not laid out that specifically. However, there is data that shows relative accident rates for different types of operations. So 2-pilot flight decks, that you're accustomed to with Part 135, the airlines, and some Part 91 corporate operators who require it for their own purposes for the type of aircraft that requires it, for aircraft that are not certified for single pilot operations. What you see is a lower accident rate than for those airplanes that don't. And then again, as you go down and out into the different types of aircraft and operating regimes, you see even further increase in accident rates. So it's not that there is any data that I can point to specifically about single pilot versus dual pilot, but there is data that suggests those operations that are dual pilot have a lower accident rate. And you can see that in the Null report and other reports like it. I think AOPA has done some data analysis on things like that. So it does, I think, point to the need to focus on single pilot operations and enhancing them. And one of the approaches that we've taken with things like SOPs, with things like I mentioned in my presentation about a pre-flight automated FRAT and a post-flight automated debrief, those tend to replace the kinds of things that are there when you have a 2-pilot operation. When you got a guy in the right seat that's critiquing your landing, it's immediate. And when you don't, how do you critique that so that you don't have runway overruns? So yes, I think there is information out there people can point to that would suggest that focus on single pilot is warranted compared to 2-pilot operation.
Okay, very good. Thank you, Charlie. So, Dror, there's a couple of questions about the ergonomics of head-up displays and training, and how that will eventually lead to moving to reduced crew operations. In other words, as one questioner puts it, use of a HUD introduces its own automation management challenges. And how do we overcome these challenges?
So using head-up display technology, obviously the first introduction with that was not really easy because it's a fundamental change in the way pilots are flying. So we saw, and we're talking about late 90s and early 2000s, we saw some difficulties initially with pilots who didn't have any past experience, mostly from the military at that time, using this kind of technology. What we see today is that we try to see the opposite. We see today that pilots who are trained and used to fly head-up display, let's say corporate pilots going into an airline start to see some difficulties in non-head-up display operation. And after the initial training session, which is required by regulation, we start to see that the percentage on hard landing, and we can get that from airlines who are flying with or without, percentage of hard landing and incidents, and sometimes even accidents, significantly drops down. Stable approach percentage goes up, and the whole flight becomes more and more accurate. But it's a learning curve. It's not an easy one. But when it's been done, the benefits are huge. I hope I answer your question.
Thank you, Dror. And another question about a head-mounted display is whether the display goes with the pilot or does it stay on the aircraft? How do you see that working out?
So at the moment, what we have developed and designed is a system that is belong to the airplane. So it stays in a storage case inside the airplane, cannot be detached. What is personal is that every pilot has its own personal pads for hygienic purposes and sometimes for personal adjustment. So the system is an airplane retained, if that was the question.
Okay. Thank you, Dror. So, Charlie, one of the participants likes the idea of automated feedback, but wonders who's going to end up owning that data, and how do you keep it to yourself if you don't want it to be seen, let's say, by the aircraft or avionics manufacturer?
Yeah, that's a very good question, one that we're grappling with as we start to develop this. Initially, we want to have this set up such that the pilot can use this for his own purposes. It's interesting, however, a lot of the data that we're talking about is available through ADS-B, and so there's not a lot of data that wouldn't already be accessible through ADS-B that is required for some of this post-flight critique that I described. And so I think the industry at large is grappling with how do we ensure that data is managed. And I think we just need, as a community, to make sure that the governing entities and the FAA has moved in a direction of with its compliance cultural approach here of late to not using that data in a punitive fashion. The airlines have FOQA data that similarly aggregates a lot of information for their purposes on what are the trends they're seeing in operations. One that I'm familiar with was a frequent extension of flaps at too high a speed on approach to a certain airport. So there was something about that particular environment that led that to happen, and so they were able to address that situation because they had the data. But yes, in fact, what we're trying to do within our community initially, this would be in a data that would be available only to the user and the user's tablet, and not something that goes everywhere. But I think the data that is in question here, as I point out, is already going to be out there for a lot of folks to see with the advent of ADS-B more broadly. So we as a community need to address that. So,
Charlie, going a little bit further in your technology application ideas, how can a single pilot assess their physical and psychological fitness for a flight they're planning to do in a high-performance jet? Maybe you could use yourself as an example. How do you assess yourself?
Yeah, so that was really a big part of the discussion when we went to the new medical for Part 91 operators. And the reality is that you take your flight physical once a year or once every 6 months, and the doc gets to assess that you're fit to fly that day, but every other day you have to self-assess. And I think what we've tried to do is establish some common sense SOPs with the citation group that talk to things like recognizing when you're in a circadian low, and that if you're going to be landing between 2 and 3 in the morning on your body clock, that's probably not a smart thing to do. And I think just developing a culture that stays aware of those issues and not pressing yourself is important. Planning ahead to have alternatives. Typically what we do with the single pilot with our SOPs is we say that you should plan to be on the ground 12 hours after your normal start of your day. So if you are mountain time like I am, an 8 a.m. typical start of activities, I wouldn't want to be flying past equivalent of 8 p.m. Unless I did some, specific things to mitigate that fatigue factor, like having another guy with me or planning a second leg the second day and so forth. These are personal things that, it comes down to knowing, the Clint Eastwood line, a man's got to know his limitations. And I think what we've tried to do, if those who want to go online and look at our website, you'll see the SOP documents on the safety page at the CJP website. You'll see there's a part of them that speak to managing the physical. And you just can't go too deep with that because everybody has their own individual limitations, but setting some kinds of general guidelines that are best practices is a good start.
And Charlie, we should just reiterate that all that material on the Citation Jet Pilots website is free and available for anybody to look at. They can watch the video.
Yes, there's a number of what good looks like videos on there. There's each of the models have their own SOPs, the citation models, because it addresses avionics differences. And then they're all under the safety tab at CJP, which is free to anyone.
Great. So, Dror, I'm going to pull up slide 24 again. And one of the questions is, could TCAS also provide the data to show traffic on the head-up display imagery, like you're showing with? We're seeing an ADS-B target on there, but would you be able to do the same thing with TCAS?
What we do with the head-up display in TCAS is we provide the alerting and recommendation and advisory information on the head-up display on a schematic way, like climb, descent. But the ability to really superimpose the symbol on an airplane only was enabled when ADS-B out started to be deployed, because ADS-B out is a very rich message with plenty of information that helps you to do that. And the frequency is, although it's one message per second, is start to be there to allow that. So the short answer is TCAS has been presented to head-up display on a schematic way. But if you really want to identify a target, it will be only enabled only with ADS-B out and in data.
Okay.
And that's the beauty of it.
Dror, I think it's important to emphasize also your point that a wearable head-up display basically has an unlimited field of view, because you can look in any direction and you're not limited to just looking at a fixed combiner screen. So you can look up, down, side to side. And for example, if there's EVS imagery and synthetic vision, you're going to see it where you're pointing your head, right?
Exactly. And it's very important, especially when you're flying around hard terrain. And for traffic, again, if you don't want to see conflicting traffic within your primary field of view, within the 30 degrees field of view, you would like to see it on the side. It's going to be very bad news for you to see it looking forward.
And Matt, if I could pile onto that with my own experience using these wearable devices. Earlier technologies, the field of view wasn't that wide, and we used to call it looking through a soda straw. In particular, the night vision infrared imagery that turned the terrain into day was only available to you where you pointed your head, and everything around your peripheral vision was dark. So the wider field of view helps that, but it's still the periphery of this image is going to be dark at night, and the symbology is constrained to that forward-looking area. So there is some adaptation to the use of these things, but they are improving.
And I just wanted to reiterate, we had a question about the Citation Jet Pilots website. It's in the presentation, I believe, and we are going to send this material out in an email to all the participants afterwards, so they can.
Yeah, it's on the first page of my presentation.
Yeah, exactly. Then one interesting question, and Dror, maybe you're running into this, or soon we'll be dealing with it, but have you had conversations with insurance companies about the benefits of wearable head-up displays, especially as they move into other aircraft types?
Yes. So in fact, one of the operators of enhanced vision financed the installation by reducing insurance premiums. But it will be very typical to the operator and the place, the specific location which he operates. But yes, definitely, insurance companies see the benefits in that, especially with respect to safety, and that they can reduce premium, and that has been done before, reduction of premiums for adopting this technology. Yes.
And just one final question, Dror, we need to sign off, but could this be a helmet-mounted type of device, maybe that would be more suitable for helicopters, for example?
Yes, we have two systems for a pilot who does not wear helmet, and we have the helicopter version for helmet using pilots, because they use for safety reasons for against head injuries. Yes, we have those two versions, and the one for helicopter for EMS and search and rescue operation are installed over a helmet.
Great. Well, everyone, thank you very much for participating. Charlie and Dror, thank you very much for helping out with this fascinating discussion. And we'll follow up with any unanswered questions afterwards, and we will send the material to the participants. Thank you very much, and we appreciate your participation.
Thank you.